We are doing ZIMSEC Maths Paper 1, November 2021, 2 hours 30 minutes. So in this paper, you must pay attention to the instructions. Always read the instructions before you start the paper. And take note that if you omit any essential working, you may lose marks. So always show all your working and do not erase it. Write your working in the spaces outside the space for answering. Do not skip working. Omission of essential working will result in loss of marks. Must also take note of the rounding. If you do not have an exact figure to round to, just round to 3 significant figures unless you've been given or you've been specifically instructed to do something. You must not use a calculator, mathematical tables or slide rulers. And having said that, we can start. First question, express 30.098 correct to the nearest tenth. So to express it to the nearest tenth, you're going to look at the 100th figure, okay? So that 100th number there would be your 9 because the 10th figure is 0. So there's the 0, the first 0 after the decimal point is 10th, the second 9 is 100th, and the third 8 is 1,000th. So you look at the first number to the right of the one which you want to round. If it is more than 5, you are going to add 1 to the number which you are going to round, and then the other ones will be replaced by zeros. So that will be 30.1. Moving on to the second question. Express 30.098 correct to 4 significant figures. So a significant figure is the first non-zero digit from the left. So in this case, our first non-zero digit will be 3. Our second non-zero digit will be 0. Our third non-digit, another 0. Our fourth is 9. So we want to round that 9 there. So we look at the first number to the right again. So we're going to look at the 8. Since it is more than 5, it's going to add 1 to the 9. But 9, if we add 1, it becomes 10. And since it's a decimal system, we need to, the highest number there is 9. So we're going to add another 1 to the 100th, to the 10th figure. So it will be 30.10 because we need 4 significant figures. Okay, let's move on to the third one, part C. Express that number 30.098 in standard form. So by now you should know that standard form expresses number in the form a times 10 to the power n, where a is a number between 1 and 10. So a is less than 10, but it is greater than or equal to 1. So a number from 1.0 to 9.9999 fits in that criteria for a, and n is an integer, a whole number. It may be positive, or it may be negative, or it may be 0. No problem. So here in our problem, you can see that we can only divide by 10 so that our number becomes 3.0098 times 10 to the power. If we move our decimal point to the left, then our power is going to be positive. So it will be 3.0098 times 10 to the power 1, since we only moved our decimal point 1 place to the left. A thing to note about this, if the decimal point moves to the left, then the power of 10 is positive. If the decimal point moves to the right, then the power of 10 is negative. Always remember this. Let's move to the next one. Express 4 2/3 as a recurring decimal. 4 2/3 can be expressed as 4 times 3 plus 2 over 3. Okay, so that will be 4 times 3 will give us 12. 12 plus 2 will give us 14. So our answer there would be 14 over 3. And then we'll need to divide that 14 by 3. 3 into 14, that's 4, remainder 2. And we add a 0. 3 into 20, that's going to give us a 6. And then we'll remainder 2. And we add another 0. That will give us another 6. So it will keep repeating 4.666666 until infinity. So what we do here now is we just write that number as 4.6 and put a dot on top of the 6, or we can put a small bar to show that it is recurring. All right, let's move on to the next one, part B. Find the value of 10 minus 10 divided by 2 plus 2 times 2. Here we are going to use our mathematical rules of body mass or bed mass or bed mass, whichever you want. It still remains the same thing, because we're going to look at the brackets first of division, multiplication, addition, and then finally subtraction. Sometimes we may have exponents or indices. That's what the E there and the I stand for index or exponent. So here, since we do not have exponents nor brackets, we're going to create some of division and multiplication. Here we can see that we have a 10 divided by 2 in the middle there, so we're going to put it in brackets. So it will be 10 minus, in brackets, 10 divided by 2, plus, in brackets again, 2 times 2. So we're going to operate that 10 minus 10 divided by 2, that gives us 5. 2 times 2 gives us 4. 10 minus 5 plus 4 is the same as 14 minus 5. We can do the addition first and then do the subtraction later, or just straight 10 minus 5, that's 5, 5 plus 4, giving us 9. Moving on to question 3a. Write down the next term in the sequence 2, 3, 5, 8, 12. From the sequence there, you can already note that there's a pattern which the numbers are following. Between 2 and 3, there's a difference of 1. Between 3 and 5, a difference of 2. 5 and 8, a difference of 3. 8 and 12, a difference of 4. Automatically, the next number would be a difference of 5. So 12 plus 5 gives us 17. So that's the next term there. You can write it in the allocated space, 17 there. Moving on to part B. Simplify 20 minus 8 divided by 20 plus 8, giving your answer as a common fraction in its simplest form. So we'll operate the numerator 20 minus 8 and then operate the denominator 20 plus 8, giving us 20 minus 8 gives us 12 and 20 plus 8 gives us 28. Divide by the common fraction, which is 4 over 4. We get 3 over 7. Let's move on to the next question. Question number 4a. List the prime numbers between 14 and 20. So a prime number is a number which has got only 1 and itself as the only factors. In this case, you can see that all the other numbers have got factors except for 17 and 19. So the prime factors of prime factors between 14 and 20 are 17 and 19. Next part, write the number 801,008 in words. So I've already pronounced it right. 801,008. Okay, so 801,008. Just remember it. It's as simple as that. Okay, so that is good there. At least you will not miss 1 point in the exam, right? Moving on to part B. Express 6.65 hours in hours and minutes. So we're already given the hours that they are 6. So it's 6 hours plus 0.65 hours. So we want to convert that fraction or that decimal 0.65 hours to minutes. So 0.65 means that the number is 65 over 100. We can express it, reduce it to its lowest terms by dividing by 5 over 5. That will give us 13 over 20. Then we express now that 13 over 20 as a fraction of 1 hour. So 6 hours plus 13 over 20 of an hour. We will need to multiply 13 over 20 times 60 so that we can get the number of minutes, since 1 hour has got 60 minutes. So 13 over 20 times 60 gives us 20 into 21, 20 into 63, 13 times 3, 39. So therefore, 6.65 hours in hours and minutes is 6 hours and 39 minutes. 6 hours and 39 minutes. Okay, so always remember to write all the units in their correct form. Question 5. List the first 3 values of x such that 1 is less than or equal to x, which is less than or equal to 4, where x is a natural number. So the first 3 numbers there would be 1, because 1 is included, 2, and 3. Those are the first 3 numbers, and the last number is 4, which is not needed. There are only 4 numbers which are natural there. So we will need 1, 2, and 3. B. Express 270 as a product of its prime factors in index form. So to express a number and it's the product of its prime factors, we need to divide by the smallest prime factor. So we first try to divide by 2. If it's divisible by 2, we keep dividing by 2 until it cannot, and then we move on to the next prime number. So 270 divided by 2 gives us 135. But 135 is an odd number, it cannot be divided by 2. We move on to the next prime number, 3. 135 divided by 3 gives us 45. Then we divide 45 again by another prime number, 3. 3 into 45 gives us 15. 15 is an odd number, we divide by 3. 15 divided by 3, 5. 5 divided by 5, 1. So 270 can be written as 2 times 3 times 3 times 3 times 5, which can also be expressed as 2 times 3 to the power 3 times 5, or 2 times 3 cubed times 5. Let's move on to question 6a. If the bearing of P from Q is 054 degrees, find the bearing of Q from P. Remember, bearing is always written in 3 digits or 3-digit notation. This is why they wrote the 054. So to answer this question, you will need to draw a diagram. A diagram will help you to solve the work easier. Here we are drawing an angle 0.054 degrees, and always show the true north. So P is 054 from Q. Therefore, what it means is for us to get the bearing of Q now from P, we'll need to extend our lines, produce some Z angles, and work out the value of the angle between them. These lines are parallel, you can see. So our Z angle or Z angle will form between that line and that line. Therefore, that angle there is also equal to 54. So Q can be equal to 180 plus 54, which would give us 234 degrees. So the bearing of Q from P is 234 degrees. Part B, moving on to part B, it reads, calculate the number of sides of a regular polygon with interior angles of 162 degrees each. Here you can use one of two formulas. You can use the first one, which says sum of interior angles is equals to the number of sides. Sum of interior angles is equals to the number of sides minus 2 times 180 degrees. So this one will give you the sum of interior sides. So where n is representing the number of sides. So in this formula now, you can see that the sum of interior angles is equals to the size of each angle times n. So we can write as 162n is equals to n minus 2 times 180. We want to make n the subject of the formula, so we expand 162n is equals to 180n minus 360. That will give, then we rearrange, we take 60 to the left and 162 to the right. So when we've done that, our 162 will become negative and our 360 will become positive. So it will be read as 360 is equals to 180n minus 162n. 360 will be equal to 18n. 180 minus 162 is equals to 18. So 360 is equals to 18n. And then we are going to divide both sides by 18, which is the highest common factor there, to remain with n on one side. 18 into 18, 1. 18 into 18, 1. 18 into 18, 1 again. And 18 into 360, that's 2. And 18 into 0, that's 0. So the number of sides is equals to n. Alternatively, you can use another formula where you divide the exterior angle. Now, if we say 180 minus 16, we get the exterior angle. So the exterior angle is equals to 18. Then you divide by 360 divided by 18, you still get 20. Moving on to question 7. Express 1 over x squared minus 1 minus 1 over x plus 1 as a single fraction in its simplest form. So you must agree with me that here you can already identify that x squared minus 1 is a difference of 2 squares. What is the difference of 2 squares? It is a quadratic expression in which the roots or the factors are separated by the signs. One of them has got a positive sign, the other one has got a negative sign. You can only use this when second number is a perfect square. Okay, so x squared minus 1 can be equal to x plus 1 and x minus 1. So if we express that, then it means that you can see that the common denominator is x plus 1 and x minus 1, since 1 plus x is the same as x plus 1. So x squared minus 1 into x squared minus 1, that gives you 1 multiplied by the numerator 1. X plus 1 into x plus 1, x minus 1, you get x minus 1 multiplied by the numerator minus 1. Then what you're going to do is you're going to operate the numerator and then express as a over the denominator. Now 1 minus x plus 1 is the same as 1 plus 1 minus x, which is equals to 2 minus x divided by the common denominator, which is x plus 1 bracket x minus 1. Question 8, it reads, part A, write down the largest 4-digit number in base 5. So by now you should know that base 5, the highest number in base 5 is 4, because all the numbers in base 5 start from 0 up to 4. So base 5 is 0, 1, 2, 3, and 4 is the highest number. So the number which would be largest would be 4, 4, 4, 4. Alright, 4, 4, 4, 4 base 5. Convert 1, 1, 1 base 8 to a number in base 7. So here the first step is to convert to base 10, and then the second step is to divide by 7 in order to get numbers in base 7, and then what we're going to take are the remainders. So step 3 would be to write down the remainders coming from the bottom going up. The first number closest to the base is to the power 0, the next one to the power 1, power 2 until there. So it will be 1 times a to the power 2 plus 1 times a to the power 1 plus 1 times a to the power 0. This will give us 64 plus 8 plus 1, which will give us 72 plus 173 base 10. Then we convert 73 base 10 to a number in base 7 by dividing by 7. So what we'll do here, we're going to divide 73 by 7. So 7 into 73, 1, 0, remainder 3. 7 into 10, that's 1, remainder 3. And then 7 into 1, that's 0, remainder 1. Reading from the bottom going upwards, it will be 133 base 7. So our number will be 133 base 7. Let us then move on to the next question, question 9. Factorize completely x squared bracket y plus 1 minus y minus 1. So here, x squared bracket y plus 1 minus 1 can also be rewritten as x squared bracket y plus 1 minus 1. We factor it out, and then we have in the brackets y plus 1. And then we'll go on to x squared minus 1, put it in brackets as the first bracket, and then we take the common factor y plus 1. So what we will do is, we can already notice that x squared minus 1 is a difference of 2 squares. Remember that difference of 2 squares where we said one of the they are only separated by the other one being positive and the other one being a negative. So it will be x plus 1 plus bracket x minus 1. Since you know that the difference of 2 squares, a plus b bracket a minus b, can be written as a squared minus b squared. So here x squared minus 1 can be rewritten as x plus 1 bracket x minus 1, and then we multiply also by the bracket the other one, y plus 1. So this is our factorized expression. Let's move on to the next question. Question 10. Evaluate log 64 base 4. So we can use many methods. We can equate it to x, or we can just express log 64 base 4 as log 4 to the power 3 base 4. Then the 3 will go there. It will be 3 log 4 base 4. And you know that any number log x base x is equals to 1. So our answer there would be 3. So you can write your 3 there in the allocated space. Alright, let's move on to part B. Evaluate log 8 divided by log 16. Okay, we can use our method that we used above. You should know by now that 8 can be rewritten as a product of its prime factors, or as a product of its factors being 2 times 2 times 2. So log 8 can be written as log 2 cubed, and log 16 can be written as log 2 to the power 4. And then this will be simply 3 log 2 divided by 4 log 2. Log 2 will divide log 2, and then we remain with 3 over 4. So our answer will be 3/4 or 0.75. Okay, let's move on to question 11. Solve the simultaneous equations. 2x plus y is equals to 4, 5y minus 4x equals to 13. So in order to solve this, you can use several methods. You can use elimination, you can use substitution, you can use a graphical method, but here the easiest one would be to use substitution because it is very direct here. What we can do is we can rewrite that first equation, 2x plus y is equals to 4 as, make y the subject of the formula, y is equals to 4 minus 2x. So wherever we see a y, we can replace with 4 minus 2x. Let's substitute into the second equation. 5 bracket 4 minus 2x is equals to, then minus 4x is equals to 13. Therefore, we might expand the bracket. 5 times 4, 20. 5 times minus 2x gives us minus 10x. Minus 4x equals to 13. 20 minus 14x, since minus 10 minus 4 gives us 14 equals to 13. Then we rearrange the formula. 20 minus 13, we bring 13 to the left and 14x to the right. 20 minus 13 equals to 14x. 7 is equals to 14x. We divide both sides by 14, and then we'll find our value of x being 14 divided by 14, 1. 14 divided by 14, 1. 7 divided by 14, 7 divided by 7, 1. 14 divided by 7, 2. So x is equals to 1 over 2 or 0.5. Now, when we've gotten our value for x, we can now use it to find the value of y by substituting it into any of the equations to get the value of y. Okay? We can use it in the first equation, which has got a direct value of y, or we can use it in the second one. Since the first one is easier, let's take the first one. 2 multiplied by x, which is 0.5, plus y is equals to 4. So 2 times 1 over 2 gives us 1, plus y equals to 4. Then we can eliminate the 1 from both sides. Then we have y is equals to 4 minus 1, giving us y is equals to 3. So the value of x is equals to 0.5 and the value of y is equals to 3. You could have used elimination as well, but it's a longer method. In this case, it would be more direct to use the substitution method. However, all methods will bring you to the same answer. So whichever method makes you feel comfortable, it's fine. The graphical method, you have to find where the two lines intersect. You draw the line for 2x plus y equals to 4, the other one for 5y minus 4x equals to 13. Where they intersect, you take the x coordinate and the y coordinate, you'll still get the same answer. You can prove by substituting the values of x and y, and you'll get your answer is 13 in both cases. Let's move on to question 12. Find the expression 10 bracket x plus 1 and 8 bracket x plus 1 squared. For those expressions, find the highest common factor and the lowest common multiple. So for the first one, to find the highest common factor, we need to break down our number as a product of its prime factors. That's how we can find the common factors. So for 10x plus 1 and 8 bracket x plus 1 squared, we can expand it. Then 10x plus 1 can be rewritten as 2 times 5 bracket x plus 1, and 8 bracket x plus 1 squared can be rewritten as 2 times 2 times 2 bracket x plus 1 bracket x plus 1. So here the highest common factor would be, we have an x plus 1 which is common in both sides. Then we also have a 2 which is common in both sides. So it will be 2 bracket x plus 1. Okay. Then the second part wants us to find the lowest common multiple. So here the lowest common multiple is found by finding the longest chain of the factors in both the expressions 10 bracket x plus 1 and the other one 8 bracket x plus 1 squared. So we take the longest chain of factors for both expressions. Always remember this is the easiest way to find the lowest common multiple of any numbers, whether they be algebraic or not. So here we are going to take the longest chain of 2's. Where do we get the longest chain of 2's? We get it from that 8, which is equals to 2 times 2 times 2. So we take that 2 times 2 times 2 and then note it down. Then we express 10 bracket x plus 1 again. Take the longest chain of 5's. There's only one 5 there, so we take that one, and then the longest chain of x plus 1 is found in 8 bracket x plus 1 squared. So our highest common factor there would be 2 times 2 times 2, which is equals to 2 cubed. Then the longest chain of 5 is just 1 there, so we write our 5, and then the longest chain of x plus 1 is found the other side, x plus 1 squared. So our expression would read 2 to the power 3 times 5 bracket x plus 1 squared. That's our lowest common multiple for that expression. So it will be 8 times 5 bracket x plus 1 squared, which would be 40 multiplied by x plus 1 squared. Alright, so we found our answer there. Just take note to remember this. Move on to question 13. A triangle has sides of length 5 centimeters, 8 centimeters, and 12 centimeters. Find the cosine of the smallest angle as a common fraction in its lowest or in its simplest form. So here you have to sketch a triangle first so that you can see what you are doing. Label the sides. This is just a sketch, so just label any side 5, 8, and 12. Give the side the angles letters A, B, and C. The side opposite A is the small letter A. So in order to find the cosine, the angle which is the smallest is the one which is opposite the smallest side. So the smallest side is 5, so the angle there would be C in our diagram. It can be any letter on your diagram. So cos C is equals to, the cosine rule says that cos C would be equal to a squared plus b squared minus c squared all over 2ab, which would be equal to 12 squared plus 8 squared minus 5 squared, all divided by 2 times 8 times 12. So just remember to put the figures in correctly so that you don't make mistakes and you avoid losing unnecessary marks. So be careful when you are writing these figures so that you don't lose unnecessary marks for silly things, right? Then here it will be 64 plus 144 minus 25, all divided by 8 times 12, that's 96 times 2. That would give you 6 times 2 gives you 12, and then you carry 1, then 9 times 2 gives you 18 plus 1, 19. So our answer there would be equal to 192. We need to simplify this. So what we'll do is we're going to add 64 plus 144, subtract 5, and then divide by 192. So 64 plus 144 gives us, that's an 8 there. 4 plus 6, that's a 10 plus, carry 1 plus 1 gives us 2. So it will be 208. Then we're going to subtract 25 from 208. So what we will do is 208 minus 25 divided by 192. 8 minus 5 gives you a 3. Then 10 minus 2 gives you an 8. And then 2 minus 1 gives you 1. So it will be 183 over 192. We can see that it's almost divisible by 3 because the answer said that we should write it in its lowest form. In order to reduce to the lowest form, we need to find the highest common factors for both 183 and 192. And it is always best to start with the small numbers so that you keep dividing until you find the highest common factor. In this case, so we divide by 3 over 3. 183 divided by 3, that's 6. And 3 into 3, 1. divided by 3 into 19, that's 6, remainder 1, and 3 into 12, that's 4. So our answer there would be 61 over 64. So we cannot divide it anymore because there are no common factors between 61 and 64. Actually, 61 is a prime number. Just take care to divide or reduce a number to its possible lowest term where you cannot find any more common factors between the numerator and the denominator. Moving on to question 14. Solve the equation 5 to the power x is equal to 125. So here we have an exponent 5 to the power x, and we can express 125 as 5 to the power 3. Now here why we did this is it is easier for us to solve it if the bases are the same. So we can express the second number as the base of the first one, and if the bases are equal, then it means that the exponents are also equal. Okay, so it will mean that if 5 to the power x is equal to 5 to the power 3 and 5 is equal to 5, then it must also imply that x is equal to 3. And hence, our value for x is equal to 3, equation solved. Let's move on to question B. Part B says, simplify 98 over 32 to the power of minus half. Now, remember from our algebra and indices that any number x to the power of minus half is the same as saying 1 over x to the power half, and that can also be rewritten as 1 over square root of x. Remember, any number to the power of a fraction a over b is the same as a b root of that number to the power of a. So 1 over x to the power half is the same as a square root of x. So we can rewrite this number 98 over 32 to the power minus half as 1 over 98 over 32 to the power half. Okay, since we want to remove that minus, the minus is just showing that it's a reciprocal, so we can rewrite it like this, and then we will now find our square roots. So it will be the same as 1 over square root of 98 over 32. Again, according to the rules of indices, we know that any number, if we have a number a over b and we're looking for its square root, it is the same as saying the square root of a over square root of b. So in this case, it would be 1 over square root of 98 divided again by square root of 32. Okay, so here it's simple. We can find the square root of 98 and find the square root of 32 by doing the following. Right, what we do next now is we find the square root of 98 on the side. So square root of 98 is equals to, we can rewrite this as square root of 98 is equals to square root of 2 times 49, which is equals to square root of 2 times square root of 49. This would give us 7 root 2, okay, or root 2 times 7, which would just be 7 root 2. And then we also find the square root of 32, which would be equals to square root of 2 times square root of 16, which will give us root 2 times 4. And this will give us 4 root 2. Now, when we've done this, we can now factor in these numbers into our answer there. 1 over 7 root 2 over 4 root 2. 1 over 7 root 2 over 4 root 2. So remember, 7 root 2 over 4 root 2 is still the denominator. Then we cancel out root 2 over root 2 because they are common in both the denominator and the numerator. So we will remain with 1 divided by 7 over 4. Okay, so 1 divided by 7 over 4. We also know that from our knowledge of fractions, if a number is being divided a fraction, it is the same as just writing the reciprocal of that fraction. So 1 divided by 7 over 4 is the same as 4 over 7. Okay, so here our answer would be 4 over 7. That is a fraction in its lowest terms. There are no common terms between the denominator and the numerator, and hence that's the final answer there. Okay, let's move on to question 15. Given that minus 2 is less than or equal to x, which is less than or equal to 5, and 3 is less than or equal to y, which is less than or equal to 10, calculate the greatest possible value of y squared minus x squared. Here we need to find the greatest value of y, which is 10, and then we need to find the least possible value of x. So here in this case, we've been given that x ranges from minus 2 up to 5. But since the value of both x and y are being squared, then it means that the only value of x which gives us the least value of x would be a 0, because if we square minus 1, if we square minus 2, they'll give us whole numbers which are big, and hence we need a number which gives us the least. So we take the greatest value of y, which is 10, and then the least value of x there would have to be 0, and therefore if we do the subtraction, y squared minus x squared, we're going to have 10 squared minus 0, giving us a possible 100. So that's the greatest possible value of y squared minus x squared. Let's move on to the second part. It says we need to find the least possible value of x, y. So the smallest values of x and y are minus 2 for x and 10 for y. We get the largest possible value of y and take the least possible value of x, and hence multiply the two, and hence get the smallest numbers possible, okay, because that's the biggest range. All right, so because y is the highest value and x is the least value, we take the highest from y, the least from x, then multiply the two. That would be 10 and minus 2. If we multiply the two, we get minus 20. Next question, solve the simultaneous inequalities. 2x minus 6 is less than or equal to 4x less than 10 minus x. Leave them in the form a is less than or equal to x is less than b, where a and b are integers. So in order to solve this, you need to break it down into two parts, where one part is 2x minus 6 is less than or equal to 4x, and then the second inequality would be 4x is less than 10 minus x. So let's break it down. Our two equations are 2x minus 6 is less than or equal to 4x, and then the second one, 10 minus x is greater than 4x. We shall rewrite them as equations 1 and 2, so that we may be able to solve them neatly and nicely. Okay, so we'll start with the first equation, we'll solve it, then solve the second, and then we'll bring them together again to form our inequality in the required form. So 2x minus 6 is less than 4x is our first equation. 10 minus x is greater than 4x is our second equation. So 2x minus 6 is less than or equal to 4x. Then what we do here is we bring the terms with x on one side, put the other terms without x on the other side. So we subtract 2x from both sides there. We will remain with minus 6 is less than or equal to 2x. And we're going to divide both sides by 2, since 2 is the highest common factor between 4x and minus 6. So we'll get 2 into 2, 1, and then 2 into 6, we get 3. So minus 3 is less than or equal to x. That's our first inequality. Let's move on to the second one. 10 minus x is greater than 4x. It would be better to rewrite it as it is. 4x is less than 10 minus x. That would be a simpler way to solve it, because you wouldn't need to do much after you finish it and then when you want to join it. So let's rewrite it as 4x is less than 10 minus x, then we solve it that way. In this case now, it would be easier to solve it, because in this instance, when it is in this form, we just need to put them together and put x in the middle. So here, x plus 4x, we're going to put x to the left and the number 10 to the right. x plus 4x is less than 10 minus x plus x. Then 5x is less than 10. We divide both sides by 5, and then we get x is less than 10 over 5. That gives us 2. So x is less than 2. So now we have two equations. X is less than 2 and x is greater than or equal to minus 3. So we just put x in the middle, less than 2, then the other greater than or equal to minus 3. So therefore our inequality is in the required form. Minus 3 is less than or equal to x, which is less than 2. Let's move on to the next question, part B. Represent the solution to part A on a number line. This one is the easiest part. This is a free mark. So we just draw a number line. Where there's an equal to or greater than or less than sign, we put a closed circle or a full circle. And then where there's a less than or greater than sign, we just put an empty circle. Okay, so our number line here we've put from 4 on the positive and minus 4 on the negative. Our number line is starting from 2 up to minus 3. So we shade minus 3 because there's an equal to, and then we do not shade a 2. That's a free mark there. Let's move on to question 17. The next question, given that v squared is equals to u squared plus 2as, make a the subject of the formula. So this is a formula for physical relationships for velocity, given initial velocity and acceleration and displacement. Right, v squared is equals to u squared plus 2as. So we can subtract u squared from both sides. V squared minus u squared is equals to u squared minus u squared plus 2as. So it will be v squared minus u squared is equals to 2as. We divide both sides by 2s. Then we remain with v squared minus u squared over 2s is equals to a. So whatever you do on the left side of an equation, you also do on the right side of the equation, so that you maintain the equality of the equation. Part B, find the value of a when s is equals to 5, u is equals to 2, and v is equals to 2. So you simply substitute into the equation. A is equals to v squared minus u squared over 2s. So therefore it becomes 2 squared minus 2 squared over 2 times 5. Okay, since both v and u are the same or are equal, then it will be 2 squared is equals to 4, and it will be now 4 minus 4 divided by 10. So it will be just simply 0. Okay, so 0 over 10, whatever the number, doesn't matter, 0 over 10 is equals to 0. Dividing by 0 as a numerator or as a denominator, the answer is still 0. Okay, let's move on to question 18. D varies jointly as s and t. Find an equation connecting d, s, t, and another constant k. So to express this, it would be d is varying, you put the variation sign as s and t, so it will be s times t. When you remove the variation sign and put an equals, you put the constant to multiply the numbers after the variation sign. So it will be d is equals to kst. Now we're asked to find the value of the constant k, given that d is equals to 24, s is equals to 4, and t is equals to 2. We rewrite our equation. D is equals to kst. 24 is equals to k multiplied by 4 times 2. So 4 times 2 will give us 8. So 24 is equals to k times 8. Then we divide both sides by 8 to remain with k on one side and the other numbers on the other side. So 24 divided by 8 gives us 3. So k is equals to 3. So the value of k there is equals to 3. You can write it in the allocated space. K is equals to 3. Right. When you've done this, now you're asked to find the value of t, given that d is equals to 50 and s is equals to 10, using the value of the calculated constant. Okay, so d is equals to kst. Now need to make t the subject of the formula. So the formula is now d is equals to 3st. So to find t as the subject of formula, you divide both sides by 3s, and you remain with t is equals to d over 3s. Okay, so now since t is equal to d over 3s, you substitute now with the values that you've been given. D is equal to 50 and s is equal to 10. So t is equal to 50 over 3 times 10. Okay, so d is equal to 50 divided by 30. I shall write it on the other side, 50 over 30, and divide both sides by 10. Then you remain with 5 over 3, and then you remain 5 over 3 is the same as saying 1 and 2 over 3. Okay, so the value of d is 1 and 2 over 3. Moving on to question 19. The universal set has subsets A and B such that the number of elements in the universal set is 45, number of elements in A is 25, number of elements in A complement intersection B is 9, number of elements in A intersection B is the same as the number of elements in A union B complement. What do we do here? Let's try to draw our sets A and B and the universal set. Okay, so now A has got a total number of 25, including those in the intersection. We shall call the intersection X. And now we need to calculate how many are in A only, B only, what is the intersection, and how much are left in the universal set. What we do next is we're going to find the number of elements in A complement intersection B. What this means is we want the number of elements which are not in A, both in the intersection and in A only. So it means that number of elements in A complement intersection B is the elements in B only. Okay, so how do we find that? We've been given here that this number is also equal to 9. Okay, so the elements which are found only in B is equals to 9. We've been given this already. All right, so now we need to look for the other ones. So if the elements given in B only are 9, then we can produce an equation to solve this problem. Okay, so it will be 25 minus x plus that x in the intersection plus 9 plus x again, since we've been given that the number of elements which are A intersection B is the same as the number of elements outside of A union B. So it will be 25 minus x plus 9 plus x is equals to 45, the total number. So minus x plus x gives us 0, so it will be 25 plus 9 gives us 34 plus x equals to 45. Then we subtract 34 from both sides. 34 minus 34 plus x is equals to 45 minus 34. This gives us x is equals to 11. So our value there for the intersection x is equals to 11. Now it's very simple from here onwards. What we simply do is to now rewrite the Venn diagram using the given information that we've calculated for A and for B and for the intersection. Okay, so now I'm going to draw our Venn diagram here, A and B. We've been given that for A only it's 25 minus the intersection 11, so it will be 14. Intersection is 11, and for B only it's 9. We already calculated it, and the number outside of A and B, number of elements, is equals to again 11. Okay, so that is our representation of our Venn diagram. All right, so if you add up all those factors just to cross check, we can add up 14 plus 11 plus 9 plus 11. You will still come to 45. Okay, you can just do that to proofread or just cross check whether your working was correct. But since we've been working from the numbers first and coming to this, it means that it is very, very correct. So you need to be very careful when you are working out with these sets. Part B says find the number of elements in B. Already did that. 9 plus 11, including those ones in the intersection, which would give us a total of 20. Okay, let's move on to question 20. Given that function of x is equals to 3 over x plus 2, and that x is not equal to minus 2, find function of minus 1. Right, in this case now, what it means is for every place where we see x, we are going to replace with minus 1. So it means that function of x will be equal to 3 over minus 1 plus 2. This is equal to function of minus 1, which is equal to 3 over minus 1 plus 2, which will give us 3 over 1, because minus 1 plus 2 is the same as 2 minus 1, which goes to 1, and then it will be just equal to 3. Okay, moving on to part B, find the value of x for which function of x is equal to minus 3 over 4. That's very simple. So since we've been given that the value of x cannot be equal to minus 2, it means that whatever answer we find should not be equal to minus 2. So let function of x equals to y, then y is equals to 3 over x plus 2, and then we want to find the value of x. Since we've been given that y is equals to minus 3 over 4, then minus 3 over 4 is equals to 3 over x plus 2. We do cross multiplication. Minus 3 we're going to multiply by x plus 2, and then 3 is going to be multiplied by 4. Alright, so it will be minus 3 bracket x plus 2 is equals to 3 bracket 4. This will give us, when expanded, minus 3x plus minus 6 is equals to 12. And then we bring all the terms with x on one side, all the terms without x on the other side. Then it will be minus 3x is equals to, we subtract both, we add 6 to both sides, so that our term will be minus 3x is equals to 12 plus 6 is equals to 18. We divide both sides by minus 3, and then our positive value of x will be equal to minus 6. Notice that I divided both sides by minus 3 because I wanted to make the x a positive value. Okay, so because we're looking for the value of x, we found that the value of x is equals to minus 6. Moving on to question 21. It says the diagram above shows a speed time graph of a moving object. The object decelerates uniformly at 3 meters per second squared from a speed of v meters per second to a speed of 15 meters per second in 5 seconds, maintains the speed of 15 meters per second for a further 5 seconds, then decelerates uniformly until it comes to rest after 3 seconds. Now you need to calculate the value of v. Okay, so to calculate the value of v, you need to use the formula for acceleration. The formula for acceleration found by calculating the change of speed or velocity with time, because acceleration is change of velocity or change of speed with time. So we're going to say acceleration is found by delta v over delta t. Okay, that delta is just showing the change, don't worry about it too much. So acceleration equals to change with of v over change with t. Now acceleration is equals to negative deceleration. So deceleration, on the other hand, is equal to negative acceleration. So the deceleration which we want to calculate is equals to minus change of v over change of t. Okay, so the change of v is given by v2 minus v1 over change of time t2 minus t1, which is equals to minus v2 is the last or the final velocity there, which is equals to 15, and then v1 is the v that we want to calculate there. We've been given just the value v, an unknown, and then t2 is the last time there, which is equals to 5 seconds, and the initial time was 0. So here it's going to be minus, to calculate the deceleration, minus 15 minus v over 5. This is equals to minus 15 plus v over 5. Then we've been given the value of the deceleration. We've been given that it was 3 meters per second squared. So we just take that value and put there at the left side of the equation. 3 meters per second squared is equals to minus 15 plus v over 5. Multiply both sides by 5 so that we remove the fraction part. 15 is equals to minus 15 plus v, and then we add 15 to both sides so that we remain with v on one side of the equation, and the other numbers on the other side. So minus 15 plus 15 gives us 0, and 15 plus 15 gives us 30. So our value for V is equals to 30 meters per second. All right, that was fairly well. Okay, let's move on to the second part. Find the deceleration in the last 3 seconds, which is from 10 to 13 there. So remember, we've already said that deceleration is equals to negative acceleration. We've been given the value of V, we've been given the value of T. So we're going to use the same formula. Deceleration is equals to negative acceleration, which is equals to negative change in V over change in T. So our change in T will be from 13 to 10, because T is final T is 13 and the initial T is 10, and then V is going to change from 15 to 0. So our expression will be minus, in bracket, 0 minus 15, because final was 0 and initial was 15, divided by final was 13 minus 10, okay, in the last 3 seconds there. So it will be minus times minus will give you positive 15 divided by 3. So it will be 15 over 3, giving you 5 meters per second squared. Okay, so our deceleration is 5 meters per second. If we were to calculate acceleration, then it would have a negative value. Okay, so we can write our answers there. V is equals to 30 meters per second, and our deceleration is 5 meters per second squared. Okay, just take note that if it's deceleration, then it is a positive value. But if it was acceleration and it was negative, we'd write minus 5 meters per second squared. Just some mathematical semantics. Just remember that whenever you ask the problem, you need to read carefully through the lines and give the answer as per required accuracy. The last part says calculate the distance traveled in the last 8 seconds. For us to be able to calculate the distance traveled in the last seconds, we need to calculate the area under the graph, okay, which would be the area of a trapezium. So the distance traveled in the last seconds can be given by distance is equals to area under graph. Our graph forms a shape of a trapezium, so we can use a formula half of A plus B multiplied by H, because our shape there is a trapezium. We can also use the formula for calculating. You can break it down into 2 shapes, a rectangle and a triangle, of which you still need to add them up, but you'll get the same answer. Whichever works best for you, it's up to you. So I'll use the area of a trapezium, half of A plus B multiplied by H, and our A is equals to, you can take any side, you can take it as 8, and then the B would be equals to 5, and then multiply by the height, which is the V, which is 15. Then it will be half of 8 plus 5 times 15, which is equal to half of 13 times 15, which is also equal to half of 13 times 15. We're going to work it this side. We're going to 130 there plus 65, and then we are going to add the 2 together there. That's 5, that's a 9, that's a 1. So it will be 1 half of 195, or 195 divided by 2. 2 into 19, that's a 9, remainder 1, and 2 into 15, that's a 7, remainder 1, and 2 into 10, that's a 5. So that will be 97 and a half, or 97.5 meters. Okay, so you can write either as 97 and a half meters or 97.5 meters, depends with you. By selling an article for $20, a dealer made a profit of 25%. Calculate the cost price of the article. So $20 is equals to 100% plus 25% for the profit. Then the 20 can be equated to 125%, because there's the buying price included, which can be reduced to 125 over 100, which is equals to 1.25. So if 20 is equals to 1.25 of a certain number X, which was the cost price, So we can say 1.25 of x is equals to 20, and then solve to find for x. So 20 is equals to 1.25 times x, and then we can divide both sides by 1.25, both sides by 1.25, and then 1.25 divided by 1.25 gives us 1, and 20 divided by 1.25, we can rewrite it in the form of 20 divided by 1 and a quarter, which is equals to 20 divided by 5 over 4. When we divide by a fraction, is the same as multiplying by its reciprocal, which will be 20 times 4 over 5. 5 into 5, 1. 5 into 24. 4 times 4 gives us 16. So the cost price of the article was $16. Okay? So you can use many methods here, but the one for generating an equation is straightforward and makes it easier for you if you're not so well versed with proportion. Right, let's move on to the next question, part B. Given that 7t minus s over 2 is equals to s minus 5t over 3, find the ratio of ts to s. Here what we can do is to remove the fractions part by multiplying by the common denominator for both, which is 6. 6 divided by 2 gives us 3. 6 divided by 3 gives us 2. So 2 multiplied by 7t minus s is equals to 2 multiplied by s minus 5t. Okay, so we expand the brackets. 3 times 7t minus 3 times 5 is equals to 2 times s minus 2 times 5t, which is equals to 21t minus 3s, which is equals to 2s minus 10t. Then we bring all terms with t on one side, all the other terms with s on the other side. 21t plus 10t is equals to 2s plus 3s, which is equals to 31t is equals to 5s. What you can do here, you can either divide by t for both sides, or you can divide by s for both sides. Okay, so what I will do here is I'm going to divide both sides by s, so that I can find a fraction as a fraction like t over s, and then that will be I can find my ratio. So 31t can be divided by s to give us 31t over s. We divide both sides by s. So 31t over s is equals to 5. Then we divide both sides by 31. So it is the same as multiplying by 1 over 31 to both sides. So that will give us 5 over 31 on the other side, and t over s on the other side. Okay, so t over s is equals to 5 over 31. So you can see that the t is the numerator and the s is the denominator. So ts to s is equal to 5s to 31. All right, let's move on to the next question. Our paper is almost over. Question 23. A straight line L passes through the origin and the point 1, 2. Find the gradient of line L. So the origin is 0, 0. So the gradient of a line is found by calculating the change in y over the change in x. So that will be y2 minus y1 over x2 minus x1. So our y2 and x2 are in the point that we've been given there. So remember that when you are working with coordinates, the first coordinate that we've been given is the x coordinate, and the second one is the y coordinate. So what we will do is we'll take the y coordinate from that point and then subtract the origin, the corresponding of the origin, and then take the x and subtract the corresponding of the origin. So it will be 2 minus 0 over 1 minus 0, which will give us 2. So our gradient is 2. Find the equation of line L. To find the equation of a line, we first write the general equation of a straight line. Y is equals to mx plus c, where m is the gradient, which we just calculated, and c is the y-intercept. The y-intercept is where the line cuts the y-axis. Okay, so the line cuts the y-axis at 0 at the origin. So our equation will be y is equals to 2x, because our gradient is 2. The next part says find the equation of a straight line passing through the point 0, -1, which is parallel to line L. If the line is parallel to line L, it means that their gradients must be equal. For any two lines to be parallel, it means that their gradients are equal. Okay, so if their gradients are equal, it means that both of them have got the gradient of 2. Then it will be easy from there onwards. We just take the point, the x coordinate of the point, the y coordinate of the point, calculate the y-intercept, and then just rewrite our equation. So our general equation is y is equals to mx plus c, and then what we'll do next here is we're going to find the c value first, which is the y-intercept. What we simply do, we take the y coordinate from the point, which is -1, our gradient is 2, and the x coordinate from the point is 0, and then we add c, then our value is c is equals to -1. So this new line will cross the y-axis at -1. So that's the y-intercept. From here, it is very easy. Then we just rewrite our general equation. Our gradient, we've already calculated, it's 2, and then our y-intercept is -1. So our new equation is y is equals to 2x minus 1. Question 24. On a map, the distance between a point A and a point B is 10 centimeters, but the actual distance is 2.5 kilometers. Find the scale on the map, giving the answer in the form 1:n. So we know that 1 meter is equals to 100 centimeters. So 1 kilometer, which is equals to 1,000 meters, which is equals to 1,000 times 100. Why? Because there are 100 centimeters in a meter and there are 1,000 meters in a kilometer. So 1 kilometer is equals to 1,000 times 100, which is equals to 100,000 centimeters. Okay, now if the actual distance is 2.5 kilometers, it means that we just need to multiply 100,000 times 2.5. So 2.5 kilometers equals to 2.5 times 100,000 centimeters, which is equals to 250,000 centimeters. So this 250,000 centimeters now must be divided by 10 to find the actual number of centimeters there, because we right now our scale is 10 is 250,000, then we reduce it to 1 is to 25,000. The next part reads, calculate the actual distance in meters between two places which are 3 centimeters apart on the map. So we've been given that 1 centimeter is equals to 25,000, but we've been also given that if the places are 3 centimeters apart on the map, then it must mean that they must needs be multiplied by 25,000. Therefore, it is 25,000 times 3, giving us 75,000 centimeters. Therefore, we will need to convert it to meters. We divide by 100, since there are 100 centimeters in a meter. So 75,000 centimeters divided by 100 gives us 750 meters. So the actual distance would be 750 meters. Okay. Then part 2, find the area in square kilometers represented by an area of 8 square centimeters on the map. Now, we've been given the length factor, which is 1:2.5 kilometers. What we need to do now is to calculate what we call the area factor. Okay, so if length factor is 1:2.5 kilometers, the area factor would need to square both numbers. Why? Because in area we're going to multiply length by width, or distance times distance. So we're going to square the 1 and we're going to square the 2.5. So it will be 1 squared is just 1, and 2.5 squared we can calculate by the side there. 2.5 times 2.5, that will give, we have 25 times 20, that's 500, and 5 times 25, that's 125. Then we add the 2 together, that gives us 625. We divide by, we put 2 decimal places, that's 6.25. So our area factor is 1:6.25. 6.25 square kilometers. Now, we now need to calculate the actual area. This is only the area factor. So 8 square centimeters on the map is going to be represented by 6.25 square kilometers multiplied by 8. So let's do our calculation again by the side. 8 times 5 gives us 40, so we put our 0 carry 4. 8 times 2, that's 16 plus 4, 20, put our 0 carry 2. 8 times 6, that's 48 plus 2, that's 50. So the actual area is 50 square kilometers. That's the actual area, 50 square kilometers. Question 25, given that OA is equal to minus 2, 4 and OB is equal to 4 minus 2, where O is the origin, find AB. So to find AB is simply the same as saying vector B minus vector A, which is equals to 4 minus 2 minus 2, 4. Okay, so we're going to rewrite it in our column vector form. 4 minus 2 minus 2, 4. Next, what we need to do is we're going to just subtract the corresponding values, the ones on top subtracting the ones below. So 4 minus 2 will be the same as just saying 4 plus 2, and then the bottom one will be minus 2 minus 4. It's very simple from there onwards. 4 plus 2 will give us 6, and minus 2 minus 4 will give us minus 6. Next question, find the modulus of AB, leaving the answer in set form. So find the magnitude of AB is very simple. We're going to find the square root of A squared plus B squared. All right, so we're going to take the positive value of A squared and B squared, so it will be a square root of 6 squared plus square root of minus 6 squared, which is equals to 36 plus 36, which is equals to 72. And square root of 72 can be rewritten as a product of 36 and 2, so that we can find, we can make it in said form. So root of 72 can be rewritten as square root of 36 times 2, which is equals to square root of 36 times square root of 2. So we can also rewrite it as square root of 36, that gives us 6, and square root of 2 just 2, so it will be 6 root 2. Moving on, the next question is question part C. Find OM where M is the midpoint of AB. So we've already calculated AB, so we just need to multiply that vector by half. Okay, so the midpoint of AB is equals to half of AB, which is the half of the vector which we already calculated, 6 minus 6, which is equals to 3 minus 3. That's very simple. So our OM will be equal to that number there, 3 minus 3. Okay, so just be careful when you're just working it out. Remember that minus is going to multiply both numbers in the brackets or in the vector. 26, given the matrix A 1 2 3 4 and C 1 minus 4 minus 2 3, find the determinant of C. So the determinant is found by multiplying A times D, then subtracting B times C. A, B, C, and D, that's the order there. So A times D will be equal to 1 times 3 minus B is equals to minus 4 and C is equals to minus 2, so minus 4 times minus 2. 1 times 3, that's 3 minus 4 times minus 2 gives us positive 8. So 3 minus 8 equals to minus 5. That's the determinant of matrix C. Then the next part says A minus 3C. So we want to subtract 3C from A. So that will be the vector 1, 2, 3, 4 minus 3 times all the other numbers in vector C. So that's 1, 2, 3, 4, and then minus. So remember, if a number is outside a matrix like that, it's called a scalar, and it is going to multiply every number inside the bracket or inside the matrix. So 1, 2, 3, 4 minus, we're going to multiply every number there by 3. The next matrix will be 3 minus 12 and minus 6 and 15 there. Okay, then we are going to subtract. Subtracting is very simple. We're going to subtract only the corresponding numbers there, no problem. So 1 minus 3 gives you minus 2. To subtract now, that will be 1 minus 3 in the first value for A, then 2 minus minus 12 for B. For C, that will be 3 minus minus 6, and for D, it will be 4 minus 15. Okay, so in that order. All right, then we put our matrix bracket. 1 minus 3 gives us minus 2. Then the next one, minus 3 plus 6 gives us 9. Then the other one, 2 plus 12 gives us 14. And 4 minus 15 gives us minus 11. So that's our matrix A minus 3C. Then calculate matrix B if B is equals to A times 5 and 6. So what we need to do first is to determine the order of the matrix, which we will get. So since the first one is a 2 by 2 being multiplied by a 2 by 1, it means that the answer that we have is a 2 by 1 matrix. So our resultant will be a 2 by 1 matrix because we've determined that they are compatible, since the column of the first one can be multiplied by is equal to the row of the second one. So now we need to multiply 1, 2, 3, 4 by 5 and 6. That's very simple there. We're going to say 1 times 5 plus 2 times 6 for the value, or for the top value, and then 3 times 5 plus 4 times 6 for the bottom value. Very, very simple stuff. So 1 times 5 plus 2 times 6 for the top value, and then for the bottom value, 3 times 5 plus 4 times 6. Then we compute those ones. 1 times 5 gives us 5, plus 2 times 6 gives us 12. So it will be 5 plus 12. And then the second one is 3 times 5 plus 4 times 6. That will give us 15 plus 24. Then we are going to add those numbers, 5 and 12, and then add 15 and 24. 5 plus 12, 15 plus 24, we are going to get 17 for 5 and 12. Then 15 plus 24, we are going to get a 9 there and a 3 there, so that number will be 39. So our matrix B, if B is equals to A and 5 over 6, will be 17, 39. The revision does not have to end here. You can click this paper if you want to continue your revision.